Good evening, all of you. So, we had finished till Ohm's law. Ohm's law ना? कर लिया था Ohm's law? क्या किया था जरा बताया कोई? We had completed specific ohmic, non-ohmic सब खत्म हो गया था? नहीं, ohmic and non-ohmic वो भी खत्म कर लिया था. So today we'll be starting with factors affecting resistance of a conductor. We did that also. Very good. So, did we discuss VI graph?
Yes, sir.
Okay. So, chalo, start with the question. Slope of VI graph is what is the slope of VI graph? क्या देता है? Slope of VI graph is delta V upon delta I, right? What is it? क्या है वो भाई? रेजिस्टेंस. रेजिस्टेंस R देता है, ठीक है? Slope of VI graph gives resistance. Is resistance. ठीक है? ये आंसर होना चाहिए. तो मैं तुम्हें एक क्वेश्चन देता हूँ, ठीक है? I am giving you a VI graph, right? For two substances, one is this and the other is this. Okay? Let's say this is for substance B, this is for substance A. Which resistance is higher? For which substance? क्वेश्चन मुझे हंसने के लिए थोड़ी बोला है, इसको जब भी कोई बोलो हंसती है, अब मैं हंसूंगा तो वो देखते हैं। कौन सा स्लोप हाई है, ए या बी? ए, ठीक है। स्लोप क्या होता है? ए का स्लोप, बी का स्लोप। तू रोए तब तक नहीं हंस रहा है, ठीक है, उसके पहले चुप हो जा। बता अभी क्या है इसमें, स्लोप किसका ज्यादा है, ए का कि बी का ज्यादा है? ए का स्लोप ज्यादा है ना? क्यों? व्हाई? व्हाट इज स्लोप? You're going up, okay, up the hill. One hill is like this, okay, and one is like this. Which slope is higher?
The steep one.
The steep one. So what is steep here?
B is steep, yeah.
Which slope is higher?
B.
You said A earlier.
Yes.
So why?
The B is the potential difference upon current.
See, what is slope? Slope is the variation in y-axis with respect to variation in x-axis. So if you take the same comparison, so the variation in y-axis and x-axis variation is same. So y-axis variation was this much in case of B. Whereas what is the variation here? Less, right? So for A, the variation in y-axis is less as compared to B for the same variation in x-axis. Now you understand what is slope. So which graph is steeper? B. So and the slope is resistance. Slope of V versus I is R. So whose R is higher? जिसका slope ज़्यादा है, ठीक है? So resistance of substance B is more, since it is more steeper. It is more steeper. ठीक है ना? तो जो स्टीपर ग्राफ है उसका स्लोप ज्यादा है, मतलब उसका y में वेरिएशन as compared to x is more. ये मीनिंग होता है। तो अभी तक जो पढ़ाया है उससे अगर इतना समझ आ गया तो वी आर गुड. So this is the graph in your textbook. Okay, so you should be able to answer such type of questions. Okay, we have already covered specific resistance also, right? So what are the factors which will affect specific resistance? So factors affecting specific resistance. So only two: nature of substance and temperature. And temperature. So when the temperature rises, the specific resistance will rise. ठीक है? Or when you change the substance, copper to silver or copper to gold, then the specific resistance will be different. Okay? Will it change with the dimension? Will specific resistance change with dimension? No. Why? Because the way we have defined specific resistance, it is defined only for unit length and unit area of cross section. ठीक है? So कुछ भी dimension रहने दो. When we say specific resistance, it means its dimensions are frozen, fixed. ठीक है? That's it. So these are the two factors on which the specific resistance or resistivity depends. Specific resistance को ही we say or resistivity. It is one and the same thing. Okay? Your rho है ना? We call rho as specific resistance or resistivity. It is one and the same thing. Anybody remembers what's the unit? What is the unit of specific resistance? Yes, very good. L by A. So in terms of unit, this will be ohm equal to rho. L is meter divided by meter square. So rho का unit क्या हो जाएगा? Ohm meter. Understood? How to find out unit? This is all. So, that's right. All right. Then we have what is conductivity? Like resistivity is a obstruction to flow of current. So conductivity is assistance or facilitation to the flow of current. Conductivity symbol is sigma. So see, the boys have picked up now. Then this time the sound was different. So that infection is spreading fast, huh? Okay. Right. So we will go back home with different sounds today. Okay. So conductivity is 1 by rho. Reciprocal of resistivity is conductivity. ठीक है ना? So when the resistance is high, conductivity will be less. When the resistivity is less, conductivity will be high. Okay? That's why it is reciprocal. Okay. So what will be unit? So conductivity, it is defined as reciprocal of resistivity. ठीक है? Unit क्या होगा? Therefore unit is क्या होगा? Per ohm per meter. Per ohm per meter. Because this is ohm meter. Reciprocal will be per ohm per meter. ठीक है? ये Next is choice of material of wire for various application or use. Okay, so the title choice of material of wire actually means for various applications or use. So first, whenever we are using the wire for electrical connection, what kind of wire will you take?
A conductor.
Conductor, so it should have low resistance.
Low resistance.
Okay, should have least resistance. Very good. See, video is leaving a good effect on you. Huh?
No, sir, it was difficult.
It was difficult. That's why you went twice. Okay, but you have to read also. I mean, it's not like I give lecture and you'll understand everything. You have to read also. Should have least resistance. So, what is the application or use? Electrical connection. So, whenever we are connecting the tube light with the switch, it should have less resistance. Current flow should be fast. So, example, for electrical connection, what kind of wire we use?
Copper.
Copper, right? Why not silver?
Because it's expensive.
Very good. So, copper, right? Or aluminum. These two we use, not silver. Not silver. Since expensive. और उधर से हंसी नहीं सुनाई दी Do you go to this morning walk in garden? There are people who deliberately laugh. कैसे जबरदस्ती है, इतना फेक लगता है ना वो, मन करता है पास में जाके बोलो, फिर बोलते छोड़। But ठीक है, they laugh fake, but the others who listen to them, they start laughing. It's very infectious. Okay. Next application, resistance wires. So resistance. Or resistors. Yeah, what will you use? They should have high resistance. Should have high resistance. Because we need resistance wire to limit the current. पंखे में वो, are you varying the speed? Less current जाएगा तो speed less हो जाएगी, ठीक है ना? So चाहिए क्यों? चलो, resistors are needed to control flow of current, because in the circuit, ठीक है? So should have high resistance, high and stable resistance. Stable means it should not change with temperature. Okay? With respect to temperature rise.
We can't have pure elements for resistance wire, right?
No, you need
Only
alloy. Right? So examples are
Constant.
alloys, yes. Such as constant. So this is a mixture of copper and nickel, right? Is that true? Copper, nickel and aluminium again. It's not given in the book, so just search on the net. Copper and nickel, I think. Copper and nickel. Okay. Then you have manganese, which is a mixture of,
Manganese?
yes, manganese. It has nickel and I think iron as well. Either of the two, just check it out. Okay. So these alloys have high resistance. You can see in the table, in the resistivity table, you have alloys of higher resistance, 10 raised to minus 8, but 6.6. Look at all the metals, right? So generally, so manganese has 44, right? The highest metal had 20, right? So constant and nichrome. So nichrome is used for a different purpose. We'll see.
Is steel pure? It is also made up of mixed elements, right?
No. So steel is pure iron. Iron ore, when you process it, so the best grade iron is steel. Because if it is not of best quality, it will catch rust. Yes. Okay. So third, so there are various industrial processes through which we can extract steel out of iron, right? Okay, now we have next application is fuse wire. So fuse wire is a safety device, right? It is a safety measure. So how can we use fuse wire as a safety measure? So whenever there is a short circuit, a large current will flow. Okay, and if we allow that current to flow, then it will cause heat, and therefore it can catch fire. So we cannot allow more than required current to flow through the wires, right? So then fuse wire has low melting point.
So it will stop.
It will melt, so it will break the circuit. So it will stop the current, right? It has low melting point. So what is it made up of? It is made of
Lead.
and tin, alloy. It is an alloy of mixture of lead and tin. Okay, that is a fuse wire. Next here, filament of an electric bulb. So that is made up of tungsten, right? Filament of electric bulb. Have you seen an electric bulb with a filament?
The olden times.
Huh?
In the olden times we used.
In the olden times we used to use, right? Even today we use, right? Some colored bulbs, right?
But
We call it 0 watt.
But it takes a lot of electricity, so we don't use it.
Yes, now we have stopped using it because now we have better option. We have LED, which is much energy efficient than filament one, because it uses more energy, plus it doesn't give you more luminance. These LED bulbs give you better luminance, means visibility. Those bulbs are quite dim, but they are consuming more electricity because their electricity is not consumed in producing light. It produces a lot of heat. Okay, so a lot of electrical energy is wasted in a unuseful form or degraded form. So filament of electric bulb, right? So what do we use here? Tungsten. Why tungsten? Because it has very high melting point. It is used since it has high melting point. High melting point. Okay. Next is what is the last application? Heater. Last application is heating element in appliances. So heating element in appliances. So what do we use here? We use nichrome. Nichrome is used, right, to make the heating element. Like you have iron, electric iron. Electric iron mein you have a small element. So it is made up of. Is it made up of nichrome or mica?
Nichrome. Nichrome.
Chalo. So nichrome is used to make heating elements because whenever current is passed through nichrome, it creates sort of heat energy. Heating elements for devices such as electrical devices such as heater, oven. इलेक्ट्रिक ओवन होता है तो उसमें कॉइल यूज करते हैं. दैट कॉइल इज मेड अप ऑफ नाइक्रोम. व्हाट इज नाइक्रोम? इट इज एन alloy of nickel, chromium. Chromium क्या है यार? CH और Cr? Nickel, chromium and iron or copper. Just check what is nichrome. Okay, let me just give you this verification. Nickel, chromium and iron. Okay. Mixture of nickel, chromium and iron. Whereas, what was it? Constant and मिटा दिया गया. क्या था constant and मैंने क्या बोला था?
Copper and nickel.
हाँ, copper and nickel. So constant. Yes, I was right. It was copper and nickel, and manganese is alloy of, what did I say? Copper, manganese, and nickel. Not Fe. Copper. This is copper. So this is copper, manganese, and nickel. Proportion in that order. Okay. The one written first has higher proportion. Okay. Anyway, the proportion is not expected, nor is the mixture. Just this name you should know. Constant and manganese and micro. Alright, so we covered the applications, and the last part is superconductor. Any idea? What is a superconductor?
No resistance.
Lowest possible resistance, which is almost zero resistance. So, a conductor with zero resistance. Is it possible practically?
No. Is it? It's not possible. Right?
It is possible under laboratory environment at a very low temperature.
That can happen. It's not practical.
Practically not possible, but
The temperature is required.
yes, low temperature is required. However, it is achieved only at very low temperature. Very low temperatures for certain substances. So, if superconductor was available at our temperature, room temperature, then once the current starts, then since there is no resistance, okay, current will keep flowing forever without any energy. So, we will have so much of surplus of energy there because no heat. Okay, for certain substances such as we have mercury, niobium, mercury and lead. So mercury Hg, right?
Mercury
At 4.2. How much is that? 4.2 Kelvin?
4.2 Kelvin, yeah.
4.2 Kelvin. Then you have lead at 7.5. 7.25 Kelvin. And niobium, I don't know what's the temperature.
9.2 Kelvin.
So at these temperatures, you know what is this temperature in degrees Celsius? Almost minus 269 something for this, 268, minus 268. Very, very low, minus 268 degrees Celsius, right? So it is very close to absolute zero. So, and we live in what temperature? 300 plus Kelvin, right? If you take 27 degrees as the room temperature. Okay? So we are still far away from using superconductors. Right? So with this we are done with part A. Now we'll get into part 2. So any questions? So we did the theory. stencil is it? So now. Okay, now I'll put it on silent. I realize everybody silent mode please. So second chapter, second unit. So B part of current electricity. The first topic is electromotive force. Right? So first and foremost, the short form is EMF, right? This is EMF, and the symbol is this, epsilon, capital epsilon. What do we call it? Epsilon. This is how it is pronounced. Okay. So what is this EMF? Is it some kind of force? It is not force, but we still call it a force because of historical reasons. But is potential difference. What is it? It's the potential difference across the terminals of the cell when it is not in use. मतलब फ्रेश पीस दुकान में रखते हैं ना, तो क्या रहता है, वो यूज होता है क्या? नहीं, तो वो टाइम उसका पोटेंशियल डिफरेंस विल बी मैक्सिमम because it is not in use, right? Not in, when it is not in use, that is when no current is drawn from it. Drawn from it. You didn't learn from it. अरे उसको साइलेंट करने सिखाओ यार वो। क्या ये साइलेंट किया? घंटी के ऊपर क्रॉस आना चाहिए। क्या किया था दूसरा ब्राइटनेस तो हंसे ही, अब तो उसको हंसने को मिलेगा। कैसे रुका पाऊंगा मैं उसे? साइलेंट करना हो तो ब्राइटनेस कम कर दिया। कोई नहीं, इस बार क्या किया? साइलेंट हुआ? चलो, I believe you. Okay, it is not force, right? But is potential difference across the terminals of the cell when it is not in use. तो cell कैसा होता है? मार्केट से जब हम लेके आते हैं, तो cell ऐसा दिखता है, है? तो जो ये वाला साइड है, the upper one, it is positive, and this side is negative. ठीक है? सेल पे क्या लिखा रहता है? How many volts? 1.5 volt ऐसा लिखा रहता है। So this is not EMF. It is the terminal potential difference. The terminal potential difference क्या होता है वो हम सीखेंगे, ठीक है? ठीक है? So the potential difference between these two, इन दोनों के बीच में जो potential difference है, when there is no current drawn, this is EMF. EMF मतलब अभी करंट नहीं ले रहे हैं बस,
So open circuit.
Yes, open circuit voltage is EMF. Got it? Now, so how do we define it? So, but we know that. So, what? How do we define it? We define it as EMF is equal to work done in taking a charge, okay, throughout the circuit. Now, suppose we have a circuit. How do we define EMF? Let us say we have this. छोड़ो ये नहीं बनाते हैं एक मैंने सिंपल इलेक्ट्रिक सर्किट बना दिया. So what is electric circuit? It is a closed conducting path. It's a closed conducting path, right? Which consists of electrical devices. Pay attention. This is little tricky to understand. Okay.
What is K?
It has disease has spread this side. Yo. Huh? Where phone bajega?
So what is K?
K is key.
K is key.
Switch key.
Yeah. So this is not in use. This circuit is not in use.
No, right now it is in use.
So E will be.
Then E will. So right now I am not showing internal resistance of the cell. So E is the potential difference. So now listen. I will tell you what is what. So when the cell is in use, okay, then whatever is the potential difference, that is called terminal potential. It is less than E. Okay. So the cell is shown as, what is the symbol of this cell? This is the internal resistance and this is the full cell. Now what is all this? Hey, pass over here. Pay attention here. This is the structure of the cell. अब की बार जो हंसा कर देखो उसको मैं बाहर करता हूँ सीधे. So इसके अंदर क्या है? सेल का स्ट्रक्चर क्या है? It has a positive electrode, right? Which we call it anode. And we have a negative electrode which we call it as cathode. Okay? So then this is connected to the. So ये point हो गया. ये क्या हो गया? Plus. ये क्या हो गया? Minus. These electrodes are generally one. This is made up of copper. This is made up of zinc. Let us say. Okay. And then you have electrolyte. So you have electrolyte. So this is electrolyte. What is electrolyte? It is
Conductor.
It is aqueous solution of some acid, dilute. So then in aqueous form, it will exist as ions, positive ion and negative ion. Okay. So now it will react with copper. So it will accept 2 electrons, right? And it will make positively charged. Because now electrons will come here. 2 electrons will come here. Right. So from where these electrons are coming?
From the electrolyte.
So from the electrode. So hydrogen ion will react with copper. So these electrons will come here. Then this will become hydrogen gas. So H2 gas will come out. So what is happening? How these charges are created here? Due to chemical reaction between the electrode and electrolyte. Likewise, what happens in this case? These electrons will go and get deposited here. Okay? So then here what will be created? There will be a zinc sulfate will be created over here. Okay? So here you have deposition of negative charges. So again, this chemical reaction will go on. and therefore there will be a charge deposit. So there will be a high potential. I said positive is high potential, this is low potential. So potential difference is created. That is called. This reaction will go on for some time so that this increase of deposits will increase. Now it will become so positive, right? That now this positive charge it will repel. It will not react now. After equilibrium state, that is called equilibrium state. After that, it will stop reacting, and that's when there will be some potential difference. Okay. So there are different composition of electrolyte, electrode, etc. So we have different types of cells available. What are they? We have voltaic cell, right? So voltaic. Then we have Leclanche. Then we have Daniel cell. So these are different types of cells available. So at equilibrium, the potential difference, that is E, EMF is 1.08 volt in case of voltaic cell, 1.5 volt for Leclanche, and we have 1.08 volt again for Daniel. So there are various companies who manufacture these cells. So the one we get in India is like we are using whenever we buy these cells. So we use, you can see it. Go home today and see if you have any cell. Do you have cell? At least in the wall clock will have it. Just check. It will be 1.5.
That it will be written.
Yes, that's what we have to check. Okay, so that is 1.5. Is it clear? Yes. So now this is how, now when is this voltage? When the cell is not in use. But when we use it, then what happens? Now we have connected some load to it. Okay. So there is now potential difference. Once the conducting path is there, then the current will begin to flow through it. Okay. So how is current flowing? In the outside circuit from anode to cathode, and in the inside circuit from cathode to anode. So here it is conductor. Conductor has less resistance. Whatever resistance is due to the load, because you connected bulb or heater or anything. So it is this resistance of the load. Conductor has no resistance. But the electrolyte substance has its own resistance, and that is called internal resistance of the cell. Got it? So whenever we have a cell, it is represented as the electrodes and the internal resistance together. So this full thing will have EMF E and internal resistance R. Some cells we assume that the internal resistance is 0. In that case, we show this as there is no R, right? So when we just show E, that means the internal resistance is 0. So your question, in this case we are assuming there is no internal resistance, that's why. But in general, wherever there is internal resistance, there will be a small resistance drawn, and that is your cell. Is it clear?
Internal resistance close to the cell.
Yes, close to the cell, like this. So in the circuits where this small resistance, small r is close to the cell, it is the internal resistance of this cell. It is not the external resistance like this.
External cell resistance is.
Yes, external resistance is the resistance of the load or appliance. Got it? Because connecting wire has no resistance or least resistance, so we don't show that. So these are just connecting wires. This resistance is of the load. Clear? सबको समझ आ गया? And ये load को drive करने के लिए हमको source of current चाहिए. So cell is the source of current. समझ आ गया? ठीक है? So potential difference here. So cell is source of current. ठीक है? So what is battery? Combination of cells. So a combination of cells is called battery. ठीक है? तो ये तो EMF मैंने explain कर दिया. There is one more definition of EMF. since EMF is potential difference only, so it has to be defined in this form, right? So what is that work done? So EMF of a cell is also defined as work done in taking a unit positive charge through the full circuit. What is full circuit? Full circuit is external circuit and internal through the cell. Okay? Outside and inside the cell. That is outside the cell as well as through it. So that is full circuit. Right? So therefore, if W is work done in taking a charge Q through full circuit, then so what is this EMF? So EMF E, epsilon you write, EMF E, okay? EMF of a cell is also defined as this. So if W is work done in taking a charge Q, then what is EMF? By unitary method? Yes. It is work done per unit charge. This is what it is.
Capital Q is charge or small q any?
Anything, it's okay. I mean, Q is charge. Okay? So it's, but you should be consistent. You don't change the symbol. Whatever symbol you have taken, use that.
For the whole paper.
For the whole process, whichever process you are following. So this explanation and is EMF clear to you? So factors that affect EMF. It's just the nature of electrode and amount of electrolyte, right? Or the electrolyte used. So the material of electrode depends on the material of electrode. And the electrolyte used, the type of electrolyte. Like instead of S2SO4, if you use HCl, so the property will be different, right? Instead of copper and zinc, we use some other substance. Then the EMF of the cell will change. These are the different types of cell structures available. So what are the things it does not depend on? Does not depend on the size and shape, right, of the electrode. It does not depend on. Is that all? I mean, you have to write it word to word, okay? The shape of the electrode, the distance between the electrode and amount of electrolyte. Shape of electrode, It does not depend on shape of electrode, distance between electrodes, and the amount of electrolyte. Amount of electrolyte. So this is clear to everybody that EMF is also a potential difference only. It is not a force. Okay. So historically क्यों use करते हैं? क्योंकि current के लिए the charge has to be moved, and to move anything, force is needed. So force needed to move the charge, electromotive force. Force to move electro, that is charge. Yeah. So that is an old concept. इसलिए आज तक use कर रहे हैं, but it is actually potential difference. ठीक है? Next topic is terminal potential difference. Now terminal potential difference is V. So what is it? So I'll just modify it. Any doubt in electromotive force? Okay. Next is terminal potential difference. Its symbol is V, and this is also potential difference only, but in a different situation. It is the potential difference between the terminals of the cell when the cell is in use. पहले क्या था? It was not in use. So in this situation, तो अब इसके बीच में जो potential difference होगा, it will be V, not E. And therefore it is shown outside the terminal. ये point और ये point same ही है. Got it? So it is.
So there's 2 points.
Any 2 points outside the cell. See, when the cell is in use, let us say it is connected in the circuit now. Then this potential difference is V now. What is E? When it was not in use. Now it is connected to R. Okay? See, it is the situation has now changed. Now the cell is connected to external circuit.
So it is the opposite of EMF.
Both are potential difference only in different situation. One is the potential difference, that is the full potential difference. Right? But now it's like you ate and you sat, you have full energy. Now your mom said, ठीक है चल 10 kilo ऊपर ले गया. So is the situation different now? Now you are a little tired. So your energy level is not same as it was when you just ate. You will have now less energy. That's what it is. Because some energy is needed to maintain you. Isn't it? Some energy is gone in respiration, this, that. All my stored energy is not available for outside work. That is why on cell, terminal potential difference is mentioned, not EMF. Because this is the capability of the cell to do work, not the full EMF. Because some energy will be wasted in overcoming internal resistance. Got it? So some energy is needed for our own upkeep. Okay? So it is the potential difference across the terminals of the cell when it is in use. That is when current is drawn from it. Now the definition has changed. Okay? Write down. Terminal potential difference means it is the potential difference across the terminals of the cell when it is in use. That is when current is drawn from it. So now you draw this circuit which has both the terminal potential difference as well as the EMF. Right? Because when you start working, the food that you have eaten remains inside only, no? It's not just going away, right? That's why. So both are shown together. But now you show this as well, a small resistance. Then it becomes full. In the previous diagram also you can show a small resistance. And this is the only diagram. Okay. So you don't have to write this. This you don't need to write. Okay. ये डायग्राम भी बनाने की जरूरत नहीं है. ठीक है ना? This hope you understand. This resistance you need not draw. Run from it. Okay. This also you need not write now. Just this. So what is terminal potential difference of a cell? So this is alternate terminal potential difference. Terminal potential difference of a cell is also defined as through external circuit. That is outside the cell only. Now not through. Got it? So what is terminal potential difference? Only the work done in outside circuit. Or from here to here. Between one electrode to other electrode. Not in the cell. Got it? So if W, so now here we will say if W dash is the work done in taking a charge through external circuit, then E, instead of E now what is the symbol? E is equal to W dash Q. Because now the work done is W dash. It has to be different then. Right. So this is your terminal. So this is a positive because it is not minus. So there should be a positive charge. Okay? Remember that earlier also it was positive. Then we have voltage drop. Inside the cell. This we are using small b. When current flows inside the cell, the charge is taken inside the cell. Right. Then the work done will finish that W dash against internal resistance. Of the electrolyte. The charge is taken inside the cell, then the work done W against the internal resistance R. Again, it is charge Q only, yeah? Right? Is expressed as V dash is equal to, this is not W, it's just W. Work done inside the cell. So what is the potential difference? Just moving the charge inside this. Okay? That's it. So now these are the three equations. So this is equation 1, this was 1, this is 2 and 3. Sorry, 2 and 3. Right? So W must be the total work done. Total work done is equal to work done in the external circuit and internal circuit. So W must be equal to W dash plus small w. Right? Therefore, W is equal to. In the next class, we'll continue from here. Okay, I'll see you.
Thank you so much.